So, welcome everybody to Head First Machine Learning. I literally won't spend too much time on who I am because you're here for machine learning, you're not here for me. Just to be very shortly, I'm 27. I've been working since 2017. I've got a bachelor's and a master's in computer science. I've been previously head of artificial intelligence for my previous employee, and now I'm a technical leader inside the OpenReply. This in photo is a typical picture of me spending money in one of my drag, which is music, but whatever. So what are we going to do in this course? So this course is intended to give you an insight of what is machine learning, how it works, how usually it works, and where you should pay attention when working with machine learning stuff. Prerequisites for this talk. So first of all, you surely need to be at least being familiar with Python. I mean, you don't have to be expert level. You can always also be new by a level. That doesn't matter. The most important thing is that you get the core concepts of the machine learning. You need to be curious for machine learning, of course, and please write down all your questions for the Q&A time. I'll be going straight ahead throughout the slides, and then I'll be here for your questions. So when do we get started? Now, but before going on, I'd like to give an introduction to what is artificial intelligence. Actually, there really isn't a correct definition of artificial intelligence right now in the community. The one that I like the most is this one from the Politecnico of Milan that states that artificial intelligence is a branch of computer science which studies the behavior of the development of hardware and software systems that are equipped with abilities similar to the human ones. This is, I believe, it's the most one that gets close to what usually we do in machine learning. So does this mean we're going to build Cylons from Battlestar Galactica? No, we definitely are not going to build robots. Well, not yet, I mean. Actually, we are working with professional machine learning because we will build a machine learning system that will try to understand whether a Pokemon can be legendary or not. This is a really simple toy project, but it helps in the idea of getting inside the machine learning. Before going on, we need to introduce some terminology which is really needed when going to machine learning stuff, but also data science stuff. The first one is the data set. You could say conceptually, okay, I mean, you say data set might be like a set of data. Well, yeah, you can think as a data set as a collection of data. Then you could also reply me, but hey, we can also say that maybe even a database can be a collection of data. That could be technically right, because if we want to see from a certain point of view, yes, databases can also be a collection of data, but that's not technically how datasets works, because they can come in many flavors. They can be, as I said, database, they can be Excel files, they can be CSV files. It happened. I never saw them until I started digging during my computer science masters. They can be in JSON formats and CSV files as well. They are the most frequent, etc. And the problem is that they're not even neat at all, because we can say that the dataset is a representation of a language. I mean, there's like the dataset of the that one on the upper right should represent like the statistics of a certain area in the United States of America. So that represents a language, we could say so. The one on the down on your left, represents some economic stuff of some companies. So they all represent some stuff, and it's our job in the pipeline of machine learning to understand how to deal with them and how to fit them to a machine learning system. So the first core concept of machine learning is that we need to be able to interpret what we are given as data, get some insights of it, and understand whether we are missing something or not, which is the thing we're going to do right now. So we said that we want to build a machine learning system that predicts whether a Pokemon can be legendary or not. So this is the problem. Step one usually is to find data. Well, luckily, this time we're safe because we have the data set. Doesn't really happen that much often in real life. Who works in machine learning may relate this. So this first step actually is the longest because you need to find your data. This sometimes relies on scraping the web. Sometimes it relies on your database or your data on the company. Or some other times it relies on digging on the web for finding something. After you find your data, you just need to load into memory. And this is as simply as writing these 2 lines of code. We will describe shortly what this library is, but importing a dataset in memory is really simple, actually. Then comes from what I believe is the most hardest part, which is all the data-related stuff. So the data preprocessing. The data preprocessing is a very fundamental phase in a machine learning pipeline because you need to understand your data, as I said, and this is the occasion where you do that. There are some steps to do this. The first one is the feature engineering. It's the phase where you do the feature selection, identification of features, extraction of new features, etc. So in the left, we see our data set, the data set that we were given. So we see that we have a number, which is the number in the Pokédex of the Pokemon, the name, the types, and also some stuff, the generation to which it belongs to, and a column which is called legendary. So this is our first insight of a data set. And the second insight that we should give to the data set, it's this one here. It's called the correlation matrix. Correlation matrix is fundamental because it allows us to understand how variables are statistically correlated between each other. Okay, if you have read the abstract of my talk, you would say, you promised us no math, so why are you talking about statistics? Because that was not a lie, but there are some times in which we can't hide that much math from machine learning because we need it. So a machine learning system does need a good data set, and a data set to be, let's say, usable, it has to be statistically good. In order to do this analysis, we can rely to 2 libraries. It depends on the type of approach that we want to follow. The first one is Pandas. That was the one that we saw here that I was importing. The second one is called koalas. When should we use them? Well, it depends on our approach or in our use case. For example, we might use Pandas if we don't really need, if we need the classic approach, so just loading the memory and that's it. A second one, it's advice for a distributed approach. So when you have so much data, then maybe it's better to do a sort of big data stuff. And we'll use this throughout this whole talk. Why Pandas? Well, Pandas, it's the most used library to read TSV files, CSV files, Excel files, and so on. And it can help a lot in gathering some statistics from a data set. For example, we can calculate the mean of a specific column. We can calculate the median of a specific column. And we can also calculate the correlation matrix of the data set. As I said, the correlation matrix is very important because it allows us to understand how the variables are correlated between each other. A good correlation value usually is between 0.3 and 0.7. That's because when the system learns, it's like when we study, we need to understand the concepts of the page. If the variables are too much correlated between each other, the system is not able at all to, let's say, divide those concepts and say, okay, this is concept 1 and this is concept 2. So this is very important. Yeah, and this is very important. That's not the only thing that Pandas can do. There can be a lot more that Pandas can do. It's a really powerful library, but there's no really time, so we just stick to this, which is very important for the scope of this course. Remember just one thing, that if the dataset is too much correlated, maybe it's best to put the dataset in the trash and start your research once again. Because if the dataset is too much correlated, it can be really painful to work throughout it to resolve this correlation of it. And maybe it's even best to find new data and start all over again. Then it comes the step of erasing data because, okay, that's wonderful. We found our data set, which was here. Okay, this is our data set. Well, I mean, it looks fantastic. Might be good for a machine learning system, but not all the times we can use all the data that we see in a data set. Consider that a machine learning system is a mathematical system. So, in your opinion, given this data set on the left, what should we be dropping, in your opinion? Other, other suggestions? Okay, the name, it's a card one. We could also drop the number of the Pokédex, but you'll be surprised to know that it actually has an impact in the machine learning system of this, actually. We're talking about like the 5 or 10% of the accuracy, so we'll just skip it. We're actually going to drop the Pokemon's name, as somebody from the audience suggests, and we're gonna drop the Pokemon types. We could actually keep the Pokemon types, but because there is a way actually to convert strings to numbers or so to give strings to the machine learning system, but this is not in the scope of this talk, so we'll just go for dropping them. The way we drop them is throughout this function of Pandas, which is called drop, which is vital to do like so, because if you don't say to call it in place, Pandas will just reinstantiate a new data set. So if you don't reassign the available, what you've done will just be waste in the memory of your compiler. And you can see here, columns is a list of columns to drop. Columns and features can be exchangeable in terms of terms. Sorry for the joke. And as I was saying, in place allows us to avoid to reinstantiate the data set all over again. There's still one step to do in the data pipeline processing, which is to check if we have some missing data. Not all data sets come with all data. We might have some non-values, and we need to check them because the machine learning system is not able to interpret it. So how do we do that? It's easy. It's really simple, actually. We just do it with these two functions here. And this is applied on our data set. So if we see it, we see that there are a lot of false. So it seems that our data set is free of null values. So technically, we will be free to go. But you might ask, okay, what happens if we have a situation in which we have non-value values? How could we treat them? Well, that's a good point. In my opinion, there are two ways of handling none or non-values. First one is an extreme one, but you drop the entire column. The second one is that in that column, you insert the average of that column. Though I said that the first one is an extreme option, it's the one that I like the most because doing the average can be really risky. Take, for example, the income of some companies as a data set. You might have a lot of data of those companies, but those companies might be small, medium, maybe like 70% of those companies can be small, medium companies. Then we have the big techs like Apple, Facebook. If we do a median of that column, for example, on the income, being that we have Apple, Google, and company on that column, the value of the median might literally explode. So, for example, if my small little company doesn't have an income and it gets the average of the whole column, it might be not really close to reality. So that's why I say that we should drop the column if we have a situation like so. So just to give you an update, so we started from loading the dataset with Pandas. Then we started with the correlation matrix. This code has to be run either on Jupyter or Google Colab to see the matrix and stuff. Then we said that we wanted to drop some columns, and that's what we've done with the drop function called with the in place, and then we checked for null values if they were there or not. So we're midway of our talk. We now need to choose a model. So what's a model? A model is the machine learning system, effectively. So right now we just played with data, understood it, tried to see if something was missing, and we done that. What's a model? A machine learning system is basically a mathematical model that it can help us in deciding stuff. Mainly, it relies on the confusion matrix or on the metrics, some specific metrics, to understand whether the system is good or not. We have three possible models in a real case scenario: supervised, unsupervised, and reinforcement learning. Just to be extremely short, supervised, it's when you need a yes or no as an answer or a number, so the regressors. For the regressors, you choose the range. It goes from -infinite to +infinite, depends on your data set. The unsupervised approach is the clustering approach. So like when you're on Amazon or on Netflix, and you need to buy stuff, Amazon or Netflix recommends you some other stuff. And then the reinforcement learning is when you, like for example, AI in video games, robots, etc. To give you a quick glimpse, we're going to use the decision tree and the neural networks. The first one, it builds a path depending on the data that we supply in input and from the data that it studies. The second one, it's a system that it's more based on our brain. So based on the data that it receives in input, it decides what to do. It makes some calculations, and then it gives us an answer. In terms of what library can I use for my machine learning system, literally make your choice. There is literally the word out there. We have black box ML tools. We have machine learning with big data, deep learning frameworks, etc., etc., etc. The last step, when we finally have decided our machine learning system, is to train the model. To do that, we need to take the data set and split in two parts. The first one is the features, so the columns that I need to supply to the data set. So what the model will be going to study. The target column, instead, it's like the answer book. So the machine learning system has, let's say, some reference where to go to understand whether it predicted correctly or not. This applies, though, only on supervised systems. Then we rely on those in this function, which is called train test split from Scikit, which allows us to split the data set in a certain percentage in order to have a part that goes through the train phase and another one to the test phase in order to measure what the machine learning system did. Then, after we did this, we just train our system, and that's where we are. So we took the feature and the target columns that we were interested in, then we split them, and then we just instantiate our models, and then we train them. Sorry, this was cropped from the screenshot. And then we get metrics. Metrics are fundamental in the machine learning ecosystem, because they allow you to understand whether the system is, whether the system has studied good or not. In our example here, we had that the decision tree got a 90% in terms of accuracy, and the neural network got let's say, almost 90%. It's good. Could be done better, probably. But don't be afraid, because no machine learning, there are some cases, but not all the machine learning systems are 100% in the real life. So not all the tasks are at 100%. So if you don't reach 70, 90%, don't worry. Maybe you still did a good job. So to jump to the conclusions, because we're running out of time, this is essentially all that we did. So we loaded the data set. We saw if there were any non-values. We saw the correlation matrix. We dropped the columns. We splitted the data set. We associated the models, and then we fitted them, and then we calculated our accuracy. Step 7, though it may be not necessary, refine the model. Refine the model means maybe go back to step 3, so working with data, or try to use another metrics or some sort of stuff. So to go to the conclusion, so take-home messages. This has to be intended, as I said at the beginning, as a let's say 101 class, because my scope was to give you an insight of the machine learning ecosystem. There's literally the world out there. You should take Scikit-learn, which is the library that we saw right now as a playground. If you want to do something more complex, please do jump in a deep learning ecosystem, because that's what our this is the most used approach right now. And remember that the things that you know today in the machine learning world can be the things that are already old tomorrow. Thank you for coming. I hope you enjoyed this talk. I'm here now for those 5 minutes left for your questions, but I'll be here even after those 5 minutes. So I'm here for your questions now. Thank you. And sorry, because I know it was a lot to take in 25 minutes.
Thank you so much, Jimmy. That was a really amazing talk. On the Slido, we have one question here, but I don't know if anybody has a question. I'm on the count, so if you have a question, feel free to raise your hand so we can take them. Okay, one. Any other? All right, great. So I will take the question on Slido first, and then we move on to. Okay, so the question says, is koalas faster than pandas on large data sets since it's using a distributed approach? Do you want me to go again?
I'm sorry, I didn't understand it.
Is koalas faster than pandas on large data sets since it is using a distributed approach?
So let me jump back onto that slide. So yes, I said that we, to handle dataset, we either have two options. The first one is pandas, the other one is koalas. Let's say that the limit of pandas is that when we have huge datasets, it just can't do it. So pandas reaches, let's say its limit, and koalas, it should be the one to be used for the distributed approach, because koalas on the background relies on the Spark ecosystem, which has some let's say some distributed datasets. It's not really like that, but to be extremely short, koalas, when it loads the dataset in memory, splits the dataset in small pieces that can be used in a distributed approach. So that means that if you have many clusters, well, if you have available many clusters or a few clusters, you can distribute that dataset in your clusters, and yes, it will be faster.
All right, great, thank you. Now let's take your question.
Yeah, so going just like right to the beginning, can you hear me? The correlation matrix, you said, right? So you said that expresses the relation that there is between a variable and another. So just to see if I understand it, like that means that if there's zero correlation, that means that the model will not be able to get to any conclusion. And that if it's fully correlated, it means that it's just like the same variable expressed in two different ways, and it gives no information.
Okay, we can do it like in the following. So a correlation matrix is a matrix that allows us to understand how columns, variables, features, how we want to call them, are correlated between each other. When a machine learning system studies, it tries to, let's say it tries to print a line that should try to cut the correlation in two. So if you have a correlation that is 1, so like this, you can't cut because there's no line at all. So they're two correlated between each other. So the machine learning system cannot understand whether an information can be related to either 1 or 2. It will be the same no matter what. If you have a cell in which, for example, somewhere there, on the second row there's a 0.75. So if you have something like that, which should be something like this, then the machine learning system, when it studies, can cut the line. I mean, it's just an example. It doesn't really cut the line, but it can cut the line, so it can relate whether an information is referring to a certain column or another. I don't know if that answers to your question. Not really infinite, but it would mean almost no correlation at all.
All right, great. Our time is up, but there is one final question on Slido. So I don't know if you can take it super quick.
Sure.
Okay, how big tech companies are influencing ML? Is that good? Do you want me to read again?
Yeah, because I may got it, but
Okay, how big tech companies are influencing ML? Is that good?
okay. I'll give the funny answer. They'll just get too angry with you. But no, just kidding. It depends on the machine learning system, as I said. It depends on the data mainly and in what you do. So if the machine learning system is not good, maybe you should just go back to see the data that you have, understand it once again, and then see what happens with new iterations on it.
Thank you very much, Jimmy, for
Thank
the
you.
talk.
And thank you.